Okay, so this time we're going to look at what happens with a concave lens. So we'll have a different set of rules being applied here. But again, I'm going to do what I always do first, which is to draw on the axis. And then perpendicular to that, I'm going to draw on my lens itself. Nice and big. To show that it's a concave lens, instead of the arrowheads being the way we've drawn them so far, they are in the other direction. Okay, and that tells us that we have got a concave lens. Keeping the focal length the same as we've used before, so 6 centimeters. So there is still a focus on this side, 6 centimeters away, and a second focus on this side, 6 centimeters away as well. I'm putting my object 10 centimeters away, which means it starts there, and I'm giving it a height of 5 centimeters. So again, a nice simple object, just an arrow like that. Okay, so concave lens, axis, focus, focus, and object there. So we're all ready to put on our rays of light. Okay, now I always like to start with the ray of light that is parallel to the axis. Okay, so there it is. Now, with a concave lens, instead of going through the focus on this side, the rule is that it must look as if it has come from the focus on this side. So what I need to do is join up where it's met the lens with the focus on that side, and then that shows me where that ray of light is going to go, so that if I trace that back, it looks as if it has come from the focus on this side. Okay, so that is path taken by my first ray of light. Okay, now the next ray of light I draw is one that is heading for the focus on the other side. So the ray of light is going to approach the lens like so. Now the rule is, because it's heading for the focus on this side, when it comes out of the lens on this side, it will come out so that it's parallel with the axis. So the path taken by that ray of light is so. So if we follow that one backwards, it's looking like it came from that direction. So we already see we've got those two rays of light meeting, and that tells us where we're going to see the image of our arrowhead formed. But just for completion, we're going to draw the third ray of light. Now the third ray of light is the ray of light that goes through the center of the lens. Now this works in exactly the same way as it did for the convex lens. The ray of light is not refracted, so that just carries straight on through the center of the lens with no change in direction at all. So what we see there is all three of those rays of light, if we backtrack those two, and if we just follow this one, are all going to appear to have come from this point here. So that is where we are going to get the image of our object formed. Okay, so again, it's on the same side as the object. This is not something that we can project onto a screen, so this is a virtual image. It is the same way up as our object, and we can do our usual working out of the magnification. So that is the image height, which in this case is, I think, 18 millimeters, 1.8 centimeters, and our object was 5 centimeters. So a magnification is 1.8 centimeters divided by 5 centimeters. So quickly on a calculator, 1.8 divided by 5 equals 0.36. Okay, which makes sense. It's smaller, so it must be a number that is less than 1. All right, so that's the sort of diagram that we might have to do for a concave lens.